So the challenge today in controlling robots remotely is oftentimes the robot is out of your field of view. You rely on the video camera that's on the robot to guide your actions. It's sort of like looking through a straw and trying to figure out what's going on around you. In our case, we're using a 3D camera. It's called a 3D rangefinder camera. So in addition to giving you 2D information, it also gives you the depth of the image. What our technology allows us to do is to control it based off of the image that you see on the computer screen. Typically, you would control a robot using joint control. So if you had a robot that had 6 joints, you would control them each individually, or you would control it in world coordinate systems. We're actually implementing uncalibrated visual servoing, which again does not require any knowledge of the geometry of the robotic arm. The analogy we like to use is that of threading a needle. If you were to ask a person to thread a needle, they don't actually need to know exactly where the needle is and exactly where the thread is as far as XYZ coordinates. And that's exactly what visual servoing is. It gives a robot a pair of eyes. The user can look simply at the computer screen and then control it based off of the coordinate system that is attached to the computer screen. The interface that we've experimented with is a gamepad controller. We've mapped the joysticks and the buttons to directions that you would see on the computer screen. If I wanted to move to the right with respect to the image, I would simply point the joystick of the gamepad controller to the right, and the robot would figure out how to move its individual parts to execute moving to the right as commanded by the user. Using our method, there's about a 4-fold increase in speed. You can do it 4 times faster than using traditional control methods. The applications we see for this research are areas where intuitive control of a robotic arm would be important. So for example, applications would include bomb disposal or surgical applications where you would use a robot to perform surgery. So we think this research is important because it allows more intuitive control of robots, which means that you can operate more efficiently and also more safely.